but now I am recording. I guess I misclicked. Thank you. So, the first step, as I told you, I just named the vectors. You can use the alphabet, you can use the Greek alphabet, you can use numbers, it's okay. Now, I prefer letters. So for my vector A, as you can see, it's just like this. Do I have an angle?
0 degrees.
The angle is 180 degrees, but you don't need to do that, okay? The angle is 180 degrees, but you won't need it. I will show you what to do with the angle, okay? The second vector is like this, and it has an angle of 35 degrees. And it measures 150 Newton. My vector C is like that. And what is the angle that I have in C? Is it 30? Is it 70?
70.
Remember that we measured the angle from the x-axis, okay, to where I have my angle. So in total, I have an angle of 70. Remember, I have 30 and 40. So I add them both. I'm going to have 70. And it measures 120 Newton. Then I have my angle D, my vector D, which is this. And it has an angle of 40 degrees. And it measures 80 Newton. And I say find the resultant. That's it. So actually you won't need to worry with this. I just did a bigger table because from now on we're gonna work with this kind of exercises, more complex exercises. So if you want this table, I can still send it to you. Now take a look here. In the vector A, the reason why I draw it is because I want you to analyze. Where is my vector A going?
To the left.
Is it going up or down?
Going straight. Left, right.
Yes, it goes to the left,
Straight.
but vertically. Is it moving vertically?
No. Moving horizontally.
If it just moves horizontally, means that there is no y motion. There is no vertical motion. If there is no vertical motion, means that you don't have a vertical component. Which means that ay in the end is going to be 0 because it's not moving vertically. Now, the vector A is moving to the left, okay? That's something that we know so far. So the y component, we don't need to do it because we already know that the vertical component is 0, so you don't need to do it. Okay? You don't need to do it. Now, in the x component, you can use the angle as I told you, the angle over there is 180. How do I know that it's 180? Because I measure my angle from the x-axis from here, and from my x-axis to my vector A, I have 180 degrees. Yes. So this is how you measure the angle. You have 180 degrees, but you won't need it. You can use it if you want, but you won't need it. The reason is that we know that everything that goes to the left has a specific sign. What sign is to the left?
Negative. Negative.
Because you know that it's going to the left, the sign is negative. So you can just write that, you can just say that vector A, x, the component x of your vector A is going to be negative 160 Newton. Negative because it's going to the left. You can just, sorry, you can just write that, or you can calculate it by using the angle. You can also say that AX is equal to A times the cosine of 180 degrees. This is 160 times cosine of 180 degrees. How much is that?
Negative 160.
Negative 160. So you can either do the procedure with the angle, but I find it totally unnecessary because by just analyzing the direction, you can tell the answer. You cannot, I mean, if you can skip a procedure, do it. Make your life simpler. There is a procedure if you want to do it. Both answers are going to be correct.
Miss,
Uh-huh.
will you explain again how to find the angle?
Okay, remember that you have your thing, this thing, your protractor. Okay? So I measure my angle from my x-axis, my positive x-axis. Okay, so I measure my angle from the positive x-axis to the place I have located my vector. My vector is located in this side, okay? If I just put it there, over my, I can't. If I just put it here, what angle is it showing to you? Here you have 0, here you have 90, and here you have 180. That's if you want to do the procedure. But my advice is don't waste your time on that. I'm just showing you that everything has a base, okay? It's not that I just made up one day. Annie,
If it goes straight in this 90, yes, we will have the y component, right?
you will have your y component, but not x.
Okay.
If you want, I can include one more vector for you to see how to work with both.
Yes, because we can do another exercise that time.
Exactly. I'm gonna do another exercise because of the time, but I can add one extra vector that is going to be called E, and it will measure, I will say 180 Newton, just to make it interesting. Okay, so now that we have E, I'm going to put it here. And what happens with vector E? Así no era, espérate. straight upward. So we basically have an angle of 90 degrees. Okay, and it measures 180 Newton. This is what we know. But we can do just the analysis, okay, for the vector E. So how is E moving? How where is E going? Up,
It's going up.
up.
Vertical.
So E goes up. Okay. So what sign is up?
Positive.
Positive.
Positive for Y. Sorry. Is it moving horizontally to any of the directions, or it is just straight upward?
Straight
It's
up.
just straight
upward.
Okay. So it is straight upward. Means no horizontal motion, which in the end means that your component X is going to be 0 because it's not moving horizontally. So in your components table, you won't need to calculate X, just the Y component. And you already know the sign, so it means that you just have to write the value of the vector with the sign that it corresponds. So you say EY, it's going up, so it's going to be positive, and the value of the vector, how large the vector is, that is 180 Newton. Now you can do it with the angle too, but I totally recommend to skip it. The reason is because you have enough to do to work with that, but you still can work with the angle. Remember, this procedure that I'm doing is optional. EY is equal to E sine of your straight angle, that is 90 degrees. How much is the sine of 90? It's 1. 1 times 180 is going to give you 180. And it's going to give you the same answer. Okay? But as I told you, it is not necessary that you work like that. Just the analysis that you did before, that's enough, in my opinion. Just this will be enough. Yeah?
I have a question in angles in vector C and D. So, for example, vector C, it's always gonna be measured with X. It's, for example,
Yes.
I was thinking, for example, you like compare it to the line on D, the vector D. So it's a very little angle.
I don't know why I moved this. Sorry. No. I didn't miss. Sorry. More or less. Okay, so my recommendation is always measure the angle according to the x-axis. Okay, but if the angle that is given to you is from the vertical component, from the vertical axis, you know that you have to switch the trigonometric functions, just like in the homework. Okay, in this homework, I'm giving you the angle that is according to the vertical. So in the end, your x component is actually opposite, which means that you have to use the sign. You can do the procedure like this when you have angles with your y-axis, or you can use the normal trigonometric function by just getting this angle and using the normal functions that we use. That it will be up to you. In the end, I honestly prefer to work with the angle that is given, because when I need to find the mistake, it helps me to see the given angle, not the angle that I calculate after, for being more convenient. I totally prefer using this angle. So if I give you the angle measured from the x-axis like I show you here, you can do it like that, or you can say that I can measure this angle from the y-axis. In that case, I will need to find this angle that is 20. So you can do it like 50 degrees. Still going to be the same. I mean for this angle. And from the other angle, it's going to be just 20. But it requires an extra procedure. I'm not saying that it's not possible. I'm just saying that it requires an extra procedure. You can do it. Yes, you can do it. But I totally recommend to measure from the x-axis. The reason is because in the here in the protractor, as you can see, they are measured from the x-axis. That's why I prefer from the x-axis. They are measured from here, which this is your x-axis. That's why. Okay. So we're running out of time, so I need to continue with the exercise. The vector b. X component is going to be negative or positive?
Positive.
Negative. It's going to the left. The x. So this one is going to be positive. And what about y? It's going to be, it's going to be negative. What about the y? The y is going to be negative or positive?
Positive. Positive. It's going up.
It's going up, so it's going to be positive. Okay. Your vector c. X, positive or negative?
Positive. Positive. Positive.
It's going to the right, so it's going to be positive. About y, is it positive or negative?
Positive. Positive. Positive goes up.
Well, it looks very messy over there. Well, the y component goes up, so it's going to be positive. D, dx, positive or negative?
Positive. Positive. Positive.
dy, positive or negative?
Positive. Positive.
So the signs are completed, we can do the procedure. So we say bx is equal to 150 Newton times cosine
35 degrees.
35, and by is equal to 150 Newton sine of 35 degrees. The reason is that the y component is in front of the angle, so they are going to be using sine. Now, how much is bx?
122.87 tons.
122.27.
87.
87. And by is
86.04.
86.04 Newton. Okie dokies. Now, CX. CX is going to be cosine or sine? How is the angle?
Adjacent.
It is adjacent, so it's going to be cosine, okay, of 70. And it measures 120 Newton. So CX is equal to
31.04 newtons.
31.
41
41.04.
newtons.
And CY is 120 Newton. Sine of the angle. That is 70. CY is equal to
112.76 newtons.
okay, sorry. Thank you. What about the X? It's going to be sine or cosine?
Cosine.
Cosine.
Adjacent.
It's adjacent, so cosine. So it is Newton cosine of 40 degrees. The X is equal to
61.28 newtons.
61.28 newtons.
the Y, therefore, is going to be using the other component, the other trigonometric function. The Y is equal to
51.42
51.42.
42 newtons, yeah. Yes.
Yes, miss.
Miss,
And
dx
the
is
X,
61.
again, I
dx
was going
is
to ask you,
61.
that's what I was going to ask you, because the answer was not,
Yeah, we told you 61.
okay, well, it's okay, 61. Now, you know the procedure, we need to add, okay, and you will get your X component,
Miss,
and you will get your Y component.
miss, excuse me.
Yes,
I got 51. 80 times sin sine
yes,
and 40. I got 51.
Yes, in sine is 51. In cosine is 61.
yes, here is 51 in Y. The Y is 51, but the X is 61, right?
Yes.
Try to be sure if you want. Okay, now what about the X? Let's add them all.
I get negative 217.55 newtons.
Negative how much you got?
Negative 217.55 newtons.
Well, let me see.
We got negative 180.65.
That's what I got, 180.55, and do it again to make it to make sure that you have it right. In Y, all of them are positive, so you just need to add them all.
Yeah, I put one sign.
Ah, okay. Y, how much you got?
440.22. I got it. 440, miss.
Really?
Yeah, maybe I.
430.22.
I got 430.
Yeah, 430.
Okay, check your answer. The one who said 40. That's why I like that you use your calculator in my class so you can see the possible ways to commit mistake, and that way you avoid it in the quizzes, most likely. Now, here I will give you an advice. When you plug a negative sign here,
In parentheses.
put it in parentheses, because if not, it's going to give you a, well, it's going to give you a wrong answer.
Yeah.
How much is that?
I get 200. Well, adding the squares or the final answer.
Just the squares.
Okay. 217,687.55.
That's a large number. But I prefer like this. In this way, you sorry. And the answer, the square root of this answer is
466.57.
these are Newton, and then the procedure of the angle. The class will be over, but I will record it, just me and the computer, so you can have this procedure in the video. So remember arctangent, that is shift tan. Y over x. And here you have to divide by negative 180.55 Newton. The newtons and newtons will be cancelled. So this will give you arctangent of 430.22 divided by negative 180.55, close parentheses, okay, I performed this in the calculator and I got an angle of negative 67.23 degrees. So as a review, okay, remember that a totally horizontal vector like vector A won't have a y component because it's not moving vertically, and a totally vertical straight vector like vector E is not going to have x component because it's not moving horizontally, it's just going up. Same happens if you have just a vector that is going straight down, or a vector that is going straight to the right. Okay, so for this kind of vectors, always is going to be the number that it has. For example, 100 Newton, 20 Newton, 100 kilometers, and just include the sign. If it goes up, vertically up, is positive for y. If it goes left, it's negative for x. If it goes right, it's positive for x. And if it goes down, it's going to be negative for y. In this case, after you do this analysis, you'll be okay. So just don't forget the signs. Don't forget the signs. Well guys, this is it. Thank you for listening.